Hi guys, welcome to another one of DOWLATH Revision series videos, and we are at number 9 where we'll be talking a little bit about lenses. Now the lenses that we are referring to is a combinational lens question, meaning that you will have to determine what is the final image distance where the image is formed from a convex lens and then a concave lens. Now, these are possibly some of the most challenging questions that you will encounter on the lenses, and in fact, it is an example of a key past paper question from Unit 1. So let's go. A 2 cm tall object is placed 12 cm in front of a convex lens of focal length 10 centimeters. So we're going to break up the question and we are going to, as I've always taught you, pull out, apple pick the pieces of data. So we have a 2 cm tall object. I like to let the object height be OH, and of course you will state that very clearly that OH represents the object height. It is placed 12 cm, so my object distance U is 12 cm in front of a convex lens of focal length 10 cm. So F is 10 cm. One of the first things you are going to do when you look at a convex lens question is compare U and F, because as you guys know, a convex lens can produce both real and virtual images. If U is less than F, a virtual image is produced. If U is greater than F, you have a real image. So clearly U is greater than F, and in fact U lies between F and 2F, which is between 10 and 20. So I would naturally expect that my image be magnified. A concave lens is placed 35 cm away, so there is some distance D between the lenses, and it has a focal length of 20. Now, concave lenses by nature produce a virtual upright and diminished image, and when you consider their focal length value, it's actually negative 20. Right? Especially if you are incorporating it into the lens equation formula, right? The lens formula. So they asked you to determine the distance of the final image. So now that you have all of the characteristics of both lenses, I want you guys to break it down into the convex lens calculation and diagram, and then we move on to the concave. So your approach is to firstly consider the image formed through the convex lens or converging lens. So I use my lens formula to be guided as to what my value for my image is, using F as positive always for my convex lens, U as 12, I can work out V. Through my calculation, I worked out V as 60 centimeters. So my magnification works out to be 5. Initially, I used my object height as 2 centimeters, so you can construct your typical ray diagram. So you basically choose your scale and you place your object of height 2 cm 12 centimeters from your convex lens. You then have your principal focus 10 centimeters away, and you construct your first ray completely horizontal from the top of your object to your lens. You construct your second ray straight through the optical center, undeviated, and of course your third ray is going to pass through your focal length so that it meets ray number 2 at your image. Now the distance, I did find it to be 60 centimeters, and I constructed my inverted image, which is represented by this arrow, and the height, IH, image height, is found to be 10 centimeters. Now I am going to construct in this diagram where my concave lens will be positioned and how that now affects the behavior of my formed image. So placing my concave lens a distance of 35 centimeters, I am now seeing that I have a difference here of 25 cm because my image is formed 60 cm from my convex lens. So now I'm going to construct my concave lens, which is 35 centimeters from my convex lens initially. That gives me 25 centimeters. So 60 minus 35 is 25 centimeters for where my image is formed. So now you are going to, if you're doing it on graph paper, you can flip your graph paper, and what you can notice is that you are going to now consider this inverted image as your object to your concave lens, meaning that you consider now the distance u to be your object distance from your image to your concave lens. And you will, even though it's inverted, you treat it as you would a normal virtual image, in terms of you treat it like you would if it were inverted. Okay, so you are going to have this object here, and you are going to construct a horizontal ray. So I'm going to take away some of this so it's less cumbersome. Right. So now what you have to do is you have to draw the first horizontal ray. So this would have been my image, right? So you're going to consider that now as your object. So you draw the first ray to your lens. Remember, this is your concave lens. You would have drawn your second ray from the top of your object straight through your optical center. Right? That is ray number 2. This is ray number 1. Now the third ray will be divergent. That is this ray here. Now if it is divergent, how much it bends will depend on the focal length of your concave lens. Now your concave lens has a focal length of 20. Remember, this distance here is 25. So this distance here is 20. So what you will do is that you position the focus, and remember f is negative, and you can extrapolate. You do a dotted line because it just simply tells you how much your refracted ray through your concave lens exists due to the position of this principal focus. So you then diverge the rays, right? And then when you extrapolate it, they would appear to come from the principal focus, which is 20 centimeters from the lens. Where the ray 3 intersects with the ray 2 is at this point here, and that is where your image is formed. From a concave lens, your image is always virtual and it is always diminished. Now here you will find that V is a negative value, right? And it is as a result of the image from a concave lens. The image is on the same side of the object, and the challenging part of the question is for you to understand that the object, or what is considered as the object to the concave lens, was the image from the convex lens. Once you've identified that assumption, what exists here, then you can go ahead and treat it as you would a normal ray diagram. So when I measured this distance now from here to here, I got negative 11.11. And if you go back to your calculation, you would have been the difference between your image and the position between the lenses. So that is where I got my 25 centimeters. And then when I worked it down, I got V to be negative 11.11.